Right, we've got the M2 International Paper, October 2018, moments question. We've got a rod AB of mass 8m, length 2a, end A resting against a rough vertical wall, just here. It says one end of a light inextensible string is attached to point B. The other end is above the wall D, which is vertically above A. The angle between the rod and the string is 30 degrees. The particle mass Km is fixed the rod at C, and AC is 0.5A. Rod's in equilibrium in a vertical plane, perpendicular to the wall, and is at an angle of 60 degrees to the wall as shown. 6 degrees there. The tension of the string is T. Show that the T is equal to that. Right, we've got the weight of the rod acting down. We've got the tension in the string there. We've also got this extra weight. We're going to do moments about A because we don't know what's going on at the wall with the forces. There'll be a friction of the wall and a normal reaction, but because we're going to do moments about A, we don't need to worry about those. So taking moments about A, the tension in the string is trying to make the rod turn anti-clockwise, and the weight of the rod and that extra weight are trying to make it turn clockwise. So I'm going to draw some perpendicular lines to the rod, and so that angle is 60 degrees. So to make the tension perpendicular to the rod, I've got to turn it through an angle of 60 degrees. So the moment of the tension is going to be T cos 60, the component perpendicular to the rod, multiplied by 2A. It'll also have a component going along the rod, but because that goes through A, it doesn't have a moment, it doesn't have a turning force. Looking at the Km weight, that angle's 30 degrees, so I've got to turn it through an angle of 30 degrees here. So that component perpendicular to the rod is kmg cos 30, and I need to multiply that by the distance from A, which is 0.5A. The 8mg, the weight of the rod, again, I've got 30 degrees there, so the moment of the weight is 8mg cos 30 multiplied by A. I can cancel out all these A's. Cos 60 times 2 is just 1. So I've got T equals kmg cos 30 times 0.5. Cos 30 is root 3 over 2 times by half, root 3 over 4. Cos 30, root 3 over 2 times by 8 is 4 root 3. Then we can write that answer down now because I've taken a quarter, so root 3 over 4 mg out of the factor. So leaving with k from the first term, and the 4, well, it's 16 over 4, so which is where that 16 comes from. The other way to do it, of course, is looking at the perpendicular distance. The tension acts along the string, so that's the perpendicular distance. That's 30 degrees, so this angle is 60 degrees. So this length, this perpendicular distance, is 2a cos 60. For the extra weight, the right angle triangles here, that's the perpendicular distance, which is 0.5a cos 30, and the weight of the rod, that's the perpendicular distance, which is just a times cos 30. But I get the same as what I had before. Right. So the coefficient of friction between the wall and the rod is 2 root 3 over 3 root 3. It's in limited equilibrium. Find the value of K. So we're going to find out what the friction and the normal reaction are by looking at the vertical and horizontal forces. I'll need to split this one up, the tension, into horizontal and vertical forces. That angle's 30. I've got 60 there, and this is going to be a right angle triangle. 30, 30, so that angle's 30 as well. Looking at the vertical forces, the friction's acting upwards. So is the component of the tension, which is T cos 30. And then acting down, we've got the kmg and the 8mg, or k plus 8mg. I'm going to simplify this. The T cos 30, I'll take over the other side. and write as t times root 3 over 2. The t was root 3 over 4 mg k plus 16. Now we've got a rather complicated expression here for the friction. I'm going to simplify that down. The k plus 8 mg I'll leave it alone, but this simplified. I've got root 3 times root 3 over 4 times 2, so it's 3 over 8 mg times k plus 16. Now I can write this as 1/8 mg. I'll need to multiply that by 8 because I've got 8 in front. So this is 8k plus 64. And the other term, well, I've got 3 that's sort of left over, so I'll do minus 3 times the k plus 16. And that gives me 5k plus 16 inside the bracket. Looking at the horizontal forces, the R is going to be equal to the horizontal component of the tension. They're the only horizontal forces, and that's T cos 60, which is root 3 over 4, cos 60 is a half, root 3 over 4 mg k plus 16 times a half, or root 3 over 8 mg times k plus 16. It tells us the mu is 2 over 3 root 3. So using friction equals mu times R, I get this. The friction is mu times the R. The root 3 times root 3 comes out with the 3. The mg's will cancel. I can multiply both sides by 8. I'll have 5k plus 16 is 2k plus 32. 3k is 16, and k is 16 over 3.